Now we're going to share. Okay, so it's Monday, October 19th. We'll review homework from Friday. That was chapter 4, lesson 1, 2, and 3. The lecture today is on the last half of chapter 4. It's all in data, in lines and histograms. And then we'll do lab problem solving on some of the problem sets that are in 4, 5, and 6. And then we'll have our quiz. Okay, and the quiz will cover everything last week, essentially. So it's always just last week's work. Okay. Okay. So Rachel, are you still there? Okay, thank you. Just checking. Okay. So stop sharing that. And okay, back here. Okay, so are there any problems you want me to look at from the homework that was assigned on Wednesday? Anything? Rachel, did you have anything? No? Kathy? You're on mute. I can't hear you. Sorry.
I'm just looking over all the questions because I usually make notes.
Okay.
There's a problem. Oh, I know. On page 283,
Okay.
on number 9, I could not figure out where they got, the answer is C, 14/3, but I couldn't figure out where they got the 14.
Okay, well, let's look at it. Page 289. Share. 289. So I've got to go back. 289. 280. Are you sure it's 289?
Oh, sorry, 283.
Thank you. Okay. Okay, so stop sharing, share. 283. Boom, right here.
Yeah, I got the 70/15, and then you're supposed to simplify it.
Okay.
And I could understand where you get the 3, but I could not figure out where you got the 14.
Okay, so this is number 9. It's got to get. Okay, yeah. So in May, what was the ratio of the number of 2-day permits to the number of 5-day permits in May? So you find May over here, right?
Right.
Okay. And for the 2-day permits, it was 70.
Correct.
And for the 5-day permits, it was 15, right?
Right.
Yeah, 70/15. And so they want, so we're going to take that 70/15 and we're going to reduce it down. Okay, so I'll show you what I mean. 70/15. Yeah, so stop sharing that, and we're going to share my whiteboard, my paint board here. Jeez. I want to share this one. Okay, now we're going to I don't know why everything is so clunky today for me. Where's my whiteboard? Just a minute. Stop sharing. Share. There it is. Okay, thank you. Okay, so here we are, the whiteboard. So first thing I'm going to do is put that one ratio. We said it was 70/15, right?
Correct.
Okay. Well, we can factor this down to using the highest common denominator to do it. What can you divide? If you have a 0 and a 5, you can always divide by 5.
Correct.
I can take that 70 and divide by 5. Right? Divided by 5. I can also take that 15 and divide by 5. Right? Well, when I do this, what's 70 divided by 5?
Yeah, it's 14.
It's 14, right? And what's 15 divided by 5?
5. I mean, 3.
3, right? Well,
Right.
isn't that the answer?
Yep, that is.
Yep. So that's all you got to do. Find that common denominator, right, for the
Okay.
numerator. And you're just reducing that. It's a fraction. It's an improper fraction. You're reducing it down to the smallest term. That's
Okay.
all you're doing. Okay. That's how you get 14 over 2. Okay.
Mm-hmm.
Okay. Any other questions? Rachel, did you have any questions? Rachel, no. Okay. Emily, did you have any questions?
I didn't know.
Okay. So having said that, then we're going to go on to the lecture. Okay. We will do that. So stop sharing that, stop sharing. And we'll go on to the lecture. And it's in chapter 4, lesson 4. So this is all about data, okay? So data, statistics, and probability, and we'll do the probability on Wednesday. But anyway, it's just looking at tables, looking at data and how to read it and how to display it. That's what this is all about. Example 1, the table shows population figures for selected counties in 2000, 2010, and the square miles of each county, or each county.
What page are you on?
Pardon?
What page are you on?
I'm on page 280. Am I not on the right one?
Yeah. No, I'm just trying to find it.
Yeah, no, I know. I'm just.
Okay, I'm with you.
Okay. Yeah, this is where we are on page 280.
Okay.
And so anyway, so we're displaying data in a table form, right? And it's, you're to analyze the data. So you got to look at the particular table and look at the data in the table to trying to figure out what they're asking for. In this particular one, we're only looking at Adams and Davis County, so we only care about Adams and Davis County, right? So it's the top row and the fourth row down. Use the data, find the percent of increase from Adams and Davis counties. So you do them separately. So the percent increase would go to 2010, take away 2000, year 2000, divide by the year 2000, right? Remember, it's always the new minus the original divided by the original. That's where people get messed up. They usually don't know what to put in that denominator, but that's what it is. So when you say percent increase, that first data point is also in the denominator. Okay. So the first one was Adams was 15,280. This minus this divided by this original population, right? New minus original over original. And that's how you got 37%. Do the same thing with Davis. You go the 90,000 minus the 82,000 divided by the 82,000. You get a decimal form, multiply it by 100 to get percent, right? Whatever number you have, decimal fraction, or it could be a whole number, a number greater than 1, you still multiply it by 100 to get percent, right? That's a key takeaway. Okay, another way of looking at these is a pictograph, and that's where you have a picture that represents a certain amount. In this particular one, the key, you always look at the key. Seems like I've done this before. That's why I'm questioning myself here. It's pretty bad. Line plots and his measures of center. This I should be on. This is the wrong one, people. I've done this. What am I? Okay, let me stop sharing. Let me go here. Come on. It's not too. This is the wrong one. I messed myself up when I went and looked at Kathy's problem. Here we are. So my bad.
I'm sorry.
No, it's not. It's me. I should have caught. So it's lesson 4 of chapter 4, measures of center central tendency, okay? It's just, we're still talking about data, okay? This is called a frequency table, where in this particular case, you're putting the, you're listing the colors of the cars that were sold during a particular time period, and you're just marking them all off, whether it was white, black, red, green, silver, other, whatever, and you're putting the number of cars that fall into that category, okay? And so with that information, we're going to figure out, okay, there, yeah, you're looking at ratios of black cars driven to silver cars driven. Well, black cars, you've got 10, 20, 27, right? In silver cars, you've only got 9. So 27 to 9, and that reduces down because you can divide 9 into 27, also 9 into 9. So you get 3 over 1. So the ratio of black to silver is 3 to 1. Okay. Okay, numerical data is often grouped in intervals, and this second one here is an interval one, and that's, you see more of these than you do that top one. On this particular case, it's interval of ages, under 18, 18 to 24, 25 to 40, 41 to 40, 55, and then 55 and over. And it's customers by age into Louise's, Lois's or Lois's diner, okay, between for a week, essentially, a week period. Okay, so that's what we're doing with this data. And if you wanted to find the percent that was in each category, you'd have to add up all the data points, right? So you'd add everything up. And when you do that, you get 70. So then you can ask this question, well, what percent of the customers were 41 to 40 to 55? What would you do if you were asked? What percent of the customers were 41 to 55? Rachel, what would you do in that case? You can unmute, okay? Rachel, can you?
No, I know.
Yeah, thank you. So if it was 41 to 55, what would you do to get the percent that was in that category?
I'm sorry, I don't know.
Okay, well, let's talk through it then. You've got 70 data points altogether, right? Right? We if you add up all these data points, it's 70. So the question is, how many data points were in this category, 40, 41 to 55? Then you convert that to a percent. So you end up taking there's 10 divided by 70. That would give you 10 over 70 or 1 over 7, multiply it by 10 and you'll get a percent, or 100 and you'll get a percent, right? So what they asked down here is find the percentage of part is 28. What the part of 28, what is 28? 28's right, yeah. Okay, the number of customers that were between 25 and 40. So you just take that 28, divide by 70, that reduces down to 4 over 10, which is 0.4, times 100 will be 40% that fell into that category. Right? Does that make sense? If you took, just so you know, if you took, I'll write this down here and I'll show you. Okay, less than 18 was 6, 18 to 24. I'll tell you what, I'm going to go to it. I'm going to make a table, okay, really quick here.
It doesn't show where it says times 100, so that could be
Okay.
confusing.
Okay, well, that's how you convert it into percent.
Okay.
That's the important part. Darn it, I keep losing my paint deal. I don't understand. Okay, it's right here. Okay, share. Oh, I can't show them. There it is right there. Okay, so you see my paint table?
Yes.
Okay, I'm going to show you what I'm talking about here. What you're going to do is you're going to give me the, less than 18 group. How many is that? You count them up on that table. Somebody, I don't have that table in front of me now, so I need your help. What does that table say? Can you count them up?
Oh,
Okay, well, here.
5, 10, 15, 20, 30,
It's on page,
6.
just a minute.
There's 6 and
It's on
under
page
18.
288.
Yeah, that's what I
Right.
got.
So under 18 is 6, right? So
Right.
6 customers, right?
right.
Okay, then the next one is 18 to 24. I'm
So
gonna
it's
do this for a reason. How many is that?
18?
18, perfect, okay. Then the next one, 25 to 40.
28,
Okay, just a minute, to 40 is equal to 28, you said?
yes.
Okay. And then 41 to 55.
10,
10, okay. And then over 55
8,
is 8, okay. And we said that if we added all those up, it's equal to 70, right?
right.
Okay, so now all we're doing is we're figuring out what the percentage is in each one of these categories. So that first one, at less than 18, you would take the 6 over the 70, right? And you'd multiply it by 100 because we want to get it in percent. So what's 6 divided by 70 times 100? Use a calculator. Okay, Rachel, can you do that one? 6 divided by 70 times 100.
8.5.
Okay, 8.5. I'll put 8.5. Okay, so that's the first one. And then you do the second one. In 18 to 24, you say 18 divided by 70 times 100. Okay. And what's 18 divided by 70? What is 18 divided by 70? Divided by 70. I rounded up to 26, 25.7. So we'll just say 26, right? And these we have to end up with 100% is where I'm going with this. You may have to adjust that 8.5 up there, just round it to something, but right now, we're not gonna worry about it. So now it's 28 over 70. But I just want you to understand the process, right? So now it's 28 over 70. 28 divided by 70 is 0.4, so that's 40%, right? And when we're all done here, we're gonna end up with, the next one is 10 over 70 times 100, right? What's 1 divided by 7? So it's 14%. 10 divided, yeah, okay, that's right. Okay, and then what's greater than 55? We've got, it's 8, right? 8 over 70 times 100, right? And that's going to be around 10, right? What is it? 8 divided by 70. That's 11, okay? 11%. So I'm going to have to round this, so that's 15. Somehow we have to end up with 100 here because I'm rounding, so I've sloppily rounded. Round that to 11, that's 15, that's 21. I guess. So what is that going to be? 25, 65, 75, 85, 91. This is going to be 9. I'm going to round this guy up. Of course, I can't show it. I can't edit it. It's just difficult, this silly system here. Take all this out. We're rounding it up to 9. Lord. Sorry, I can't erase this any easier. But just pretend I had it out of there. And so what I'm saying is it would be 6 right there. 6 over 70 times 10 is equal to 9%. I rounded it up. So now you add up all these percents, you're going to get 100%. So total down here. Okay, so does that make sense? You see what we did? We took each one of those clumps of data points, divided it by the total, and then multiplied each one by 100 to get everything in percent. Kathy, does that make sense?
Yes.
Okay. Emily, does that make sense to you?
Yeah, it does.
Okay. And Rachel, does that make sense? Does that make sense? I mean, that's why I wanted to take the time to do one completely. So it made sense. Okay. Okay. So I'm going to move on. So stop sharing. I'm going to go on to here. And that's essentially what we were doing here. We just
Nice.
ran them up for every one of them. Okay, the same idea. So I'm going to stop sharing that and go on to the next page. Okay. Stop sharing. Share the screen. Okay. The next one's like this. Okay, these were the problems associated with that page, right? Or that first page. Let's look at one down here where we have some data. Let's do number 8 on question 7 and 8. This, again, it's a frequency table, shows the frequency of the number divided by whatever we're talking about here. It was reasons customer gave for returning clothing merchandise, whether it's wrong size, unwanted gift, found flaw after purchase, changed their mind. Okay, they're all valid reasons that a customer can use. So the first thing you want to do is add up all the reasons, right? You can't answer any of these questions until you add up all the reasons. So you've got 16, let's just do it 10, 20, 30, 35. I get 39, is that right? I do that 5, 10, 15, 20, 25, 30, 35, 40, or 44, right?
40, 44.
44, okay, so number 8, approximately what percent of the customers who returned clothing said the clothes were an unwanted gift? Well, you look at the unwanted gift, you got 5, 10, 15, 20, right?
Mm-hmm.
So you take the ratio of 20 over the total, which was 44, and multiply it by 100 to get percent, right? So if you do that, what do you get? 20 over 44 times 100. What do we get on that? Go here, boom, go to my paint page, get rid of all this stuff here. So in this particular one, we've got 20 over 44, right?
Right.
We want to convert that to percent. All we do is multiply it by 100, right?
Right.
That's all you're doing. So you can reduce this thing down. You can say it's 10 over 22 times 100. And just do it in steps, which is the same thing as 5 over 11, right? Times 100. What do they have their answer in? Is it, oh, it is percent, okay. So 5 over 11, so 500 divided by 11 is what? This approximately 20. So if you just, you could just go back, you could take this original deal, 20 over 44, multiply the 20 by 100 to get 2,000 divided by 44, and you should get whatever the answer is, 2,000 divided by 44. It ends up 45. Is that one of the answers? Yeah, it is. It's 45.45, but we're rounding, right? The closest answer on that sheet is 45, right?
Yes, yes.
So that's your answer. That's how you do that. Okay, I'm going to stop sharing that page and look at screenplay. Here's my questions. Okay. So all these are like that. That's, question 9 and 10 is the same idea, right? It's a frequency table. You just add up all to get the total and divide by the particular section that you're trying to solve for, right? In some cases you're putting it in terms of fractions. Other times you're putting in terms of ratios. Other times you're putting in terms of percent. But they're all equal, right? You can change a ratio to a fraction to a percent, right? You understand that?
Yeah.
Okay, so number 10, what's the ratio of applicants who could type at a speed above 45 words per minute to those who could type at a speed of 45 words per minute or less? So it's this divided by this, right? It's not total in this particular case. All they're saying is what's the ratio of this third and fourth group to the ratio of the first and second group, right? You got to read each one because they're all a little different. Who's could type is beautiful? Yeah, that's what that says. Okay, it's not to the total; it's to one group to the other, right? Again, just by reading it. So, type speed of 45 words. Above 45, so it's 5, 10, 15, 20, 25, 30, right? There's 30 above 45 or above, or 46 and above, right? So it's that divided by everything here. So it's 5, 10, 15, 20, 25, 30, 35, 40, 50, 60, right? Does that make sense? So it's 30 to 60, right? So then you take 30 to 60 and you reduce it down. What's the number gonna be when we reduce 30 to 60 down to?
2 to 3?
No, not
Nope.
no.
Oh, I'm looking at it backwards. So.
Well, you're not looking backwards. You're just looking at it different. So it's I'll go to the next page. I'll show you. So it's like this. So we said 30 to 60, right? And we want to turn that into a ratio. So it's 30 to 60. We can reduce 30 to 60 down, right? To the lowest. What's the highest common factor for 30 to 60?
10?
Highest would be, wouldn't it be 15 or
Well, you could do 50. We can start out with 15. There's nothing wrong with that. Let's do 15. So it's 30 over 15, right?
Oh, yeah, 2 to
Divided
3.
by 60, by 60 over 15, right? We okay so far?
Yeah.
Okay, so 30 divided by 15 is what?
2?
2, right? And what's 60 divided by 15?
30?
Not 3. How many times does 15 go into 60?
4?
4.
So it's 4, right? Now we got 2 over 4, but we can reduce that down even more, right?
To 1/2.
Exactly.
Ah.
It's going to reduce down to 1/2, right? You could have taken the original deal and divided the numerator and denominator by 30 and got 1/2. But you can do it in steps. There's nothing wrong with that. But you're going to end up with 1/2, right?
Mhm.
So the ratio is 1/2, or it's 1 to 2. Like I say, you can call it 1 to 2. You can call it 1 over 1/2, or you can call it 50%, right? It's all the same thing, right? That makes sense?
Yeah.
That's what we're doing, okay? And so the
Huh.
key in this one was to realize that you were dividing the top amount by the lower typing, the upper typing by the lower typing amount is what you were doing, right? It wasn't to the total amount, it was just one section to another section, right? Not to the total. That was key. And the other part is knowing how to convert a fraction into a ratio into a percent, right? This makes sense. So if you had a different one down here like this, you had what if it was 1/4? What's the ratio form of 1/4? In other words, this ratio right here, what would 1/4 be equal to?
0.25.
No, not, I want it like this. I want it 1/4, right? That's what I mean by the ratio.
Oh.
And then convert it to a percent. You take the 1/4 times 100, right? Because that's what we said, to convert anything to a percent, you multiply by 100. So 1/4 times 100 is what?
0.25.
25, right? Ends up being 25, right? So 1/4 to 1 to 4 to 20 to 25% are all the same thing, right? Just like the 1/2 to 1 to 2 to 1/2 to 50%, right? All the same thing. Okay. Okay. That's the takeaway on that one. Okay, I'm gonna stop sharing. Go on to the next one. And we'll go on to the next part. And share. Raisha, how are you?
Hi, good morning. I'm good. Thank you.
Good. Okay. Good to see you.
Yeah, you too.
Okay. All righty. Where are we? Okay, we're on the next page. Do I have anybody else online? Oh, everyone's here. Oh, they're all here. Okay. Thanks, guys.
Mm-hmm.
So Jessica, you took care of the cat?
I got an appointment
Okay.
for this afternoon. Yeah.
Okay. Okay.
Thank you.
Good luck with your cat. Okay. Your
Thank you. I
daughter's
appreciate
cat. Okay. Okay. Next section. Mean, median, and mode. I'm on the right page, 290. Just let me back up here. I don't know why I'm struggling this morning with everything here. I guess that is the right page. Okay. Okay, so mean, median, and mode. We're only taking two pages on this thing. People write books on this subject, so we're really going quickly, okay? We're just hitting the top part of it, very top. When you get into more math, it'll be more detailed, okay? But we're just going to hit the high points. What the mean is, what the median, and what the mode is, and how you determine what they are. That's what we're doing today, okay? So it gives the most common way is talking about the mean, which is really the average of a bunch of numbers, of a bunch of data, okay? So example 3 here. In 5 football games, a team scored 14, 21, 3, 20, and 10 points. What's the mean or average score per game? What do you have to do in that case? What do you have to do with these numbers?
Add.
You got to add them all up, right, to get the total, right? And then what you got to do is you got to divide by the number that you added up, right? So in this particular case, this all adds up to 68. You have 5 data points, divide the 5 into 68, and you get the mean, 13.6 points per game, right? Questions on that? It's just the average, but it's just called a mean, okay, in statistics. Same thing, okay? Okay, here's some more data. Example 4, during a 7-hour period, a bookstore recorded the following number of sales. Okay, so hour 1 through hour 7, it shows the number of sales. So the data points are all these, 43, 28, 24, boom, 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 like that. In this particular case, what you want to do in order to figure out what the The median is you got to put them in order, lowest to highest, okay? So usually with any data set, that's the first thing you want to do is order them, put it in lowest to highest. So you got to take all the data points, arrange them lowest to highest. That's what you've done here, right? And the median is the middle data point. And so if you have an odd number of data points, you just find that median one, right? In this particular case, it would be 36. But what if you had another data point? What if we had a data point of like 50 out here? If you had 50, then you'd have an even number. So what you do is you take the average of the two middle numbers. So if there was a 50 out here, pretend there's a 50 after the 48. So that would be 3, 6, 8 pieces of data. So you go to piece number 4, data point number 4, and data point number 5. And you see that's 36 and 37. You take the middle of it, the average, so it would be 36.5. That would be your median if you had a 50 out here. Okay? That makes sense? So if it's an odd number, it's really simple. You just find the middle point. If it's even, you've got to split the difference between those two middle points, right? If that makes sense. And that's what they're doing down here. On this one, here where you've got data points 72, 80, 80, 88, 89, 90. So you've got 2, 4, you've got 6 data points. So you look at point 3 and point 4, and you take the average, and that becomes 89. That's what they've done here. Make sense?
Yep.
Okay. Now the
That does.
mode is the other piece of data. That's the one that occurs the most. Okay. Sometimes there is no mode. Other times there may be 2 or 3 modes. So in the case where it's all individual pieces of data, there's no duplicates, there's no mode. The mode is none. Okay. But if there's a data point where there's 2 that are the same, that would be one mode. If there was another in that set of data points where there was 2 that were the same, that would be another mode. So you could have 2 modes or 3 modes or 1 mode or no modes. Okay. So you have three options there. That makes sense? It's all to do with mean, median, and mode. That's the basics. I mean, that is the basics. So let's stop sharing that and go to the next page and we'll look at some questions on it. Okay. Like I say, we're only spending a day on this. You could have a whole course on this stuff. So we're really taking the high road here. But if you take Math 98, you'll get a lot more data analysis. And if you take the STEM series, you'll get that in Math 65 and 95. So you'll get to it, but you get
Farther down the line, right?
yeah, and more detailed. Okay, so this is the practice for that. Just a whole bunch of data points, right? Data sets, right? Look at number 2, sales total for 6 weeks. Boom, boom, boom. What you're supposed to do here is figure out the mean, median, and mode for each one of these. And round the calculation to the nearest hundredth or cents, right? You may use a calculator here, okay? We don't expect you to use mental math to do this stuff. It's just, it's just working with the data sets with whatever data you've got. Let's do a simple one here. 72, 86, 100. I'm looking at number 6, 78 and 88. Okay, so I'm going to look at number 6 and we're going to do it together, okay? What's the first thing we have to do?
Do the highest and lowest.
Thank you. Very good. Exactly. That's exactly what you got to do. So you take the data, write it down. I'm doing number 6, 100, 78, and 88. And then putting it in order. There's 1, 2, 4, 6 pieces of data. Double check your data as you go. Make sure you don't lose any. So the lowest one on this is 72, right? And the next one's gonna be what?
78,
78, and the next one's gonna be what?
86,
86, and the next one,
88,
and the next one,
90.
88%, right?
90, right? And then the very last one, the highest one is 100, right?
Right.
So now you got it in order. So
Oh, wait, there was 288.
was there? Okay, I mean, I'm not, I
Or
believe.
am I not seeing that right? 90, 72, 86, 100, 88, 78, and 88.
Is there? Okay, I'm not
Oh,
looking.
yeah, you're right. Yep. you're
Am I
right.
okay? I mean, I could be
I just
wrong.
want to make sure I'm doing it right.
Okay. Well, regardless, let's assume this is right, okay? If it is right, we'll keep on going. But now what's the next thing you have to do? What would you do? I
Adam?
want to figure out what the mean is, okay? How do I figure out what the mean is?
So you add them all up and then divide them by how many sets of numbers?
Yeah. It's just gonna be sum divided by 6, right?
Right. But
And
what
so-
if there is two of the same number?
Well,
I mean,
that's
that's
fine.
possible because then it would be the mode, right?
Yeah, but it would also be, it would be the mode, exactly, yeah. But you'd also take that number and add it into the data set, obviously, you know.
Right. Yeah. Okay.
Yeah, but it would be the mode. This particular one does not have a mode, right? So the mode is none, right?
No,
But
it does. It says for each data set, find the mean, the median, and the mode.
I know that, but what I'm saying is not all of them have a mode.
Right.
So
Yeah.
the answer is none for mode. So you say
Right.
the mode is none. Okay. So what's the sum divided by 6? I haven't done this, so can somebody tell me what that is? Take 90 plus 72, or add them all up and divide by 6. What would that be?
Be
Hmm.
85.6.
Is it okay? I believe you. I'm not.
I don't know. Did anyone else get that?
I'm using a really weird calculator. I got
I know. I gotta get a different
133.
What did you
Doesn't
get, Kathy?
I got 100.33.
No, it can't. It's not that high. I mean, just look at the numbers. The highest number is 100. So it can't, the mean has to be below that. And Rachel, you said it was what, 80?
I'm doing it over again just to make sure.
Okay.
Give me 1 second because I don't even remember what I said.
Mean, I don't either. I didn't write it down.
90 plus 100 equals. So if you add them all together, the total is 443.
Okay.
And then we need to divide by 6, right?
Yep.
So 443 divided by 6 equals,
73.8.
yeah.
No, it can't be that low. I mean, look at the number. 73 is what, it's got to be in the 80s. I'm just looking at the
That's what
data
I
set,
said.
right? So 73 is not right. I'm just saying.
Oh, are you adding the other 88 in there now?
No, I'm looking at this. I'm not
72
72 plus 78 plus 86 plus 88 plus 90 plus 100. What is that? Is that 443? I mean, I haven't done it, so I don't know.
No, it's 514.
Ah, well, that's better.
Sorry.
That's okay. That's what,
First,
Yeah.
but then, okay.
I'm gonna put it down below
Okay.
here. So mean is equal to 514, is that what we said?
Yes.
Divided by 6, and what's that?
85.6.
Thank you. That
Yeah.
makes more sense, okay? So I'll take that one as the mean.
Yeah.
Well, so what do we say about the mode? The mode is what?
The mode is the value that occurs most often.
Right, and so it's none, right? There is no
Yeah.
mode. So the answer is none, okay, for mode. So now what's the median? We've got an even number of points, data points. So what do you do when you have an even number?
Oh,
It'd be 87.
It'd be 87, exactly. You just take that, the difference between the two middle ones, right?
Yes.
In other words, the difference between here and here, right? Oh, stupid thing. And when you do that, you get, it becomes 87, right? 87 is halfway between 86 and 88, right? That's
Yes.
how you get 87. So now you've got them, and so and you look at this and say, well, that's a nice set of data because the mean is 85.6. That's pretty darn close to 87. So it's a nice distribution, right? Ideally, the mean, the mode, and the median would all line up in a perfect world for any data set. That would be a normal distribution, but life isn't normal, right? I mean, there's little hiccups, and the data is only a small data set. It's not the total world. You know, have you guys seen the the data set or a histogram for IQ? You know, that follows a normal distribution. Does that make sense to you? If you took I'm going to show you something here real quick. Here, stop sharing that. And oh, I don't even have it up here. No. Oh, I can get to it really quick. Just a sec here. I actually pulled this up. Googled it. Just can't get to it. Just a sec. Okay, bear with me. Normal distribution. Okay. Now I'm gonna share. Okay. So you see my normal distribution curve? Can everybody
Yes.
see this? Okay, it's a
Mm.
nice, that's a normal distribution. You can put, and this is mu, this means this is the mean. Okay, that's the mean that's the average of all the numbers is right there. If it was an IQ distribution curve, the mean would be 100. Okay, that's the average. That's what that means. And on a normal distribution curve, you'll see 1 sigma. This is a sigma here. So it goes mu minus 1 sigma, mu plus 1 sigma. This would be 68% of all the population of the world falls within this as far as IQs. That's what that means. So if this is a 100, this is 85. This one over here is 115. That would be all within 1 sigma distribution. Go down here a little bit more. See, this is all, you know, the mirror image of this side is this side. So it's a perfect distribution. The world is, I mean, the samples aren't like this because it's not a complete distribution, but if it was, this is the way it would be. 2 sigma, you go down one more. This means that I think 97% of all the world falls within. So it's a low of 70 to a high of 130 as far as IQ. You go even one more, 3, and it's a low of 55 and a high of 145. Okay. This is a normal, this is an IQ, I mean, if I converted this to where mu is equal to 100 for an IQ, that's the way it would fall out, okay? But that's a normal distribution. The other point to note here is that the mode, the mean, and the median are all at the same value. That's the normal distribution. They're all at this high peak. Because what did we say? Well, we said the mode was the most. Well, this is the most, right? At this very top, the high, that's where most of the values fall, right? So that's the mode. It's also the mean, because that's mu, that's the average value right here, right? And it's also the median, because the median point is right here. So that's the perfect distribution, okay? I mean, but most data sample points are not like that because they don't, it could, because you have flyers and issues and all kinds of stuff, depending on how you take the data. But anyway, but that's a normal distribution curve. We wouldn't have to, I just thought that was interesting to you, hopefully.
That is, yeah.
You know,
Mhm.
a little interesting, but if you take Math 98, you'll get into that a lot more and other things, but I think it's pretty neat, and you can figure out all kinds of things by using this. And that's what people do when they run experiments and everything else. They look at distributions and try to get into a normal distribution curve. And they talk about you know, how close it is to a normal distribution curve and so forth. It's all based on that. Okay, stop sharing that. Boom. And we'll go back to what we're supposed to be doing here. Okay. Where are we?
Can we do number 8?
Sure.
I'm confused. I don't know about the median on that one.
Okay.
Number 8.
What page is that on, Raisha?
On 291.
Okay. Okay. Stop sharing, share. Set number 8. We'll definitely do it. Okay, so I have it.
I figured out the mean and the mode, but the median I'm kind of stuck on. 'Cause-
Okay. Number 8. Inches of rainfall over a 3-day period.
Yeah.
Okay, so you put 1.4,
Mhm.
1.8, and 2.5, right?
Yes.
So the mean is you're going to add up all those 3 and divide by 3, and you'll get the mean, right?
Yep, I got that.
Okay, the mode is none,
None.
right? And the
Right.
median is just going to be that 1.8. It's the middle data point.
Oh, okay.
Yeah,
That's
it's just
because
like,
they're an odd number. I
yeah,
was still thinking
it is.
number.
And
I was like,
normally,
oh my God, how do I figure that out?
yeah, no, you've only got 3 pieces of data. So
What
that's not
if
a-
there was 4 pieces of data? Then like
then you take the difference between the second and third piece. You take the average of it. That's what I was
okay.
trying to say. So I'm gonna give you here. I'm gonna show you.
Okay.
No, I'll show you. So if
Like
we
let's
have,
pretend like 1.8 and 2.5
Yeah.
was the middle.
well, wait, but if we get just a minute here. What if we have 4 pieces? So let's take 4 pieces down here. So we had 1.4 is 1, right?
Yep. 1.8
1.8. Just a
and
second.
2.5.
We're repeating here. 1.8 and 2.5. Okay, that's what we've got. So we know with the 3 pieces of data, we know that 1.8 is the median, right?
Right.
It's the middle one. It's the median. So if we had one more piece of data in here, let's say we had another 2.5. Okay.
Okay.
So if we had another 2.5, we're going to get a different mean. The average is going to be higher than what it was.
Right.
But also, our median is going to be between, it's going to be between the average of these two right there, right?
Right.
You take the average. So in this particular case, it would be 0.7, it'd be 3.5. So it'd be 2.15, right? Yeah, 2.15. Isn't that the average? Is
2.15.
that right?
Okay. But what if you don't know that? How do you figure that out?
What do you mean you don't know? Well, you just figured it out. What do you mean you don't know? You take 1.8 plus 2.5 and divide by 2.
I would see if I was to figure it out, I would have been like, oh, it's 2.2.
Well, it's not it's 2.15 though,
Right.
right? So I mean, you have to you got to take these numbers and take that,
Okay.
divide by 2. That's all, right?
Okay.
Does that make sense?
Yes, that does.
So that's it.
Got it. Okay.
Okay, and we took
Got
it because we took the average between those two. Okay, and by doing this, now we have a mode. The mode is 2.5, right?
Right.
Because there's 2 pieces of data here. And the mean is higher than what it was because we've added a higher number, right?
Yes.
Okay, so that all makes
Thank
sense?
you. Yes, that does to me.
Okay, is everyone happy with that one? Okay, silence is consent, okay, as we say.
Yes.
Okay, moving on. So any others on that page? On that page? If not, we'll go on. Let's go on. Okay.
No, that helped a lot. I
Okay.
was getting stumped on the points.
Okay, well, good. I want to make sure everyone gets that.
Yeah.
That's a key takeaway in this stuff. Okay. So moving on. 292. Okay, so now we've got line plots, okay? A line plot is just a line with plotting the distribution or the frequency of the data, right? And I do this when I do, it's a histogram is what it is, really. And I do this when I do tests, and I haven't done it in this class because it's a small little class and we haven't had very big tests, but I'll give you an example of how I use this histogram or line plots to do things. So stop sharing here. I want to show you something. Yeah, right here. Okay, so stop sharing. Share right here. Okay, can everyone see my screen?
Yes.
Okay, this is a histogram of a test that I gave last fall, and I did it for all the tests I gave for Math 65. What it shows is what the grade that the person got. If somebody got between a 30 and a 31, they would get one of these. Another person, so it'd be like that. So people got, two got within here, one got here, one here, and you can see the distribution, right? This is the histogram. And then what I did, I figured out what the mean was, the median, and the mode. And I did this for every test, and I would go over it with them so that it does two things. One, it shows people where they are in relationship to the other people. It also shows statistics and how to use statistics. Okay, so I did this for every test I did. And then I also put what an A, B, and C is over here too. So it seemed to be very, very helpful. In the old days, I used to put this on when I taught like probably 30 years ago, and we didn't have any of this technology. Everything was on the board. I just draw a little line on the board and put little X's, just like on that first little line distribution thing that we looked at. And that's the way I would do it. But now it's so easy to do it in Excel and other things, and you can figure this stuff out so easy. So that's the way you do it. But this is an application of using the statistics, okay? I did this for every test, so you could see what the median, the mean, and the mode was, you know. And people could actually apply that and figure out where they were, whether they're in the median or above it or below it or whatever. Do it that way, okay? So that's just a little aside. Now we'll go back and we're back here. Okay, line plots. Line plots leads to a histogram. It's sort of the same thing. It's a poor man's histogram, basically. Okay, put it like that. Everyone understand this? I'm going over this part pretty quick, I guess, but okay, we'll look at example 2 here. Students of Mrs. Jones's class took a math test. Their scores on the test are displayed on the line plot below. Each dot represents a student which grades displayed the highest frequency. So it's got D's, C, B's, and A's, and the number of students that got in each category. Does that make sense?
Yep.
It's just like that Excel spreadsheet I showed you, only instead of little dots, I've got blocks, right? It's the same idea. Okay, we'll go on to the next page. That was 292, 292, 293, 293. Okay, this is questions for the little line plots. Oh, here's let's do number 1 together, even though you have to do it. I thought it would be a good one to go over. Zoologists have combined the number of stripes on certain zebras in a zoo. The set of data from these observations is represented in the following frequency table. Interesting that you would count the number of stripes on various zebras, right?
Yeah.
You know, well, this one's got 24 and this one's got, none have 25, see? But look, 11 have 26, none have 27, 28 have 11, 29, 30 have 11, 31 nothing, and 32 has 1, right? So you have quite a distribution of this. So the question is, you put this into a line plot, okay? So which line plot represents this set of data is the question. So how would you do that? What would be the simple way of doing that, or an easy way, put it that way? How would you do that? I want to know whether it's A, B, C, or D that represents this table. How are you going to do that?
So 125, it would be.
It's really not that hard once you,
It'd be C.
it would be C, exactly, because look at 24. It has 1 here. Well, A has 0, B has
Mhm.
0, C has
Gotcha.
1, D has 1. So it could either be C or D, but then look at number 25. 25 has
Right.
0, so this is 0, this is 1, so it's got to be C.
Gotcha.
See how to do that? It's just
Mhm.
process of elimination, but it's pretty simple. You only have to look at 3 little data points, or 2 data points, really, to determine. You don't have to look at the rest of this stuff, right? That makes sense?
That was
Yes.
almost too simple.
I was thinking that for number 1, we had to choose between A and B, and for number 2, between C and D.
Oh,
But I'm looking at, I'm like, neither one of those work.
right, right.
That's what threw me off.
Yeah, I got, oh, that makes sense, sort of. Okay. Yeah, they don't. Yeah, it should say which line plot represents data. You'd put A or A through D or something like that there. But I
Yeah.
see. Yeah.
Well, I would have used them all if they wouldn't have put underneath each.
Yeah, I know. You're right. The data isn't
Yeah.
displayed very well.
They would have,
C
yeah.
or D should be over here.
I'm just very black and white.
You're right, right. You can't, don't overthink it. That's another
I
thing.
know. Yeah.
Don't do that. Just come up with your first deal.
I
and
have a
go with
problem
it.
with that.
Okay. So you understand how that's how you do that. I'm going to move on.
Yeah.
Okay. Okay.
Yeah.
Only got a couple more pages here then. Yeah, this stuff is we're going over just a lot of stuff in a short period of time. And now we're doing a histogram. Well, again, it's just like a line plot. It's just a fancier way of saying it, right? And I like it better. It sort of looks better in my mind. Same idea. Whole bunch of data divided by groups, by groupings. In this particular case, it's dates are the groupings, and the frequency are here, right? Number of appointments per these days. It's a veterinarian, okay. Or to get shots is what it is. Histogram, okay. And then you can have it by percent application, number of appointments. You can make that y-axis whatever you want, right? However you're collecting data. And the x-axis is just groupings of whatever, in this case, right? In this case, it's dates. And in my case, it was just scores on the test, right? Between 30 and 31 is one group, 32 and 33. That's how I grouped it. But you can group it by however, okay? So let's go on to the next one. Stop, share. Okay. Stop, share. Okay, boom, here we are. Turn this upside down. Okay. This is practice for that. It shows some histograms. You look at these, are there any normal distributions here? This B certainly isn't a normal distribution. It's skewed all the way to the right? This one's the normal is not in the center. The mean is not in the center. Here the mean is over to the right. So none of these are real normal distribution curves or close to normal. This is sort of as close as you get down here. But anyway, that's not the question. So frequency table used to. Oh, so this is the same idea. Look at the data collected here. It's the hours, and it's the number of people who downloaded or printed coupons between these particular hours. And you're supposed to find the histogram that matches this data set. So look at number 1. We'll do number 1 together. You know what you're going to have to do? The first thing you're going to have to do is add up all these. Well, not really. No, you don't have to, we don't have to figure out percent. All we got to do is look at the margins over here. So make sure that 1, 2, 3, 4, 5, 6, 7, 8. So this one here represents 9 a.m. and then it's 10 all the way up to 4 p.m. We'll look at 9 a.m. there's 30 here, so you look for a 30. It's got to be that one, right?
C, yeah.
The C, right? And look at 10, 56, yeah. That's not, so that's how you do that. Does that make sense?
Mm-hmm.
You just find, yeah, that's really not that hard. Again, we're not figuring out what sigma level is and all, some of the statistical stuff you do. All we're trying to do is identify what the histogram would match up with the particular set of data. And that's all you're doing down here. Okay? That all makes sense?
Yes.
Yeah.
Okay, so what we're going to do is we're going to take a break, 10 minutes, then we'll come back and have lecture, and then about probably 9:40, I'll upload the test and let you take the quiz, right? And then we'll just go from there, okay? So take a 10-minute break, okay, and we'll get back to 9:20, and then we'll do for 20 minutes, then we'll have our quiz, okay?
Okay.
Sounds good. Okay, stop sharing that. 9:20, okay.